Welcome to the session on functions and graphs, the modulus function. The objectives for this session are to understand and use the modulus function. The modulus function or absolute value function is a function of the type y equals bar f of x bar. When f of x is greater than or equal to 0, mod f of x equals f of x. When f of x is less than 0, mod f of x equals minus f of x. The modulus of a number a, written as mod a, is its non-negative numerical value. So, for instance, mod 7 equals 7 and mod minus 7 equals 7 also. On your calculator, you can use the abs function. Let's take a look at an example. Write down the values of the following, as shown on your screen. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example 1a first. The positive value of minus 3 is 3, so mod minus 3 equals 3. For part B, the value of 7.5 is already positive, so mod 7.5 equals 7.5. And finally part C. If we tidy up the fractions, or subtract one from the other, we have 7 over 28 minus 8 over 28, putting them over a common denominator, which equals minus 1 over 28, which of course equals 1 over 28. When we take the modulus. And now for the next example. Pause the video and have a go. Press play when you're ready to view the solutions. So in this example, we suppose that f of x equals mod 4x plus 2 minus 1, as shown on your screen. And then we're required to find the values of f of 3, f of minus 8, and f of minus 1 over 4. When solving this, it is important to work out the part in the modulus first, and then the rest. So let's solve part A first. We are required to find the value of f of 3. So let's plug in x equals 3 into f of x, as shown here. This equals mod 14 minus 1. Of course, mod 14, because it's already positive, is equal to 14. And of course the minus 1 is tagged on as well, to give us 13. And now for part B, we are required to find the value of f of minus 8. So let's solve this. Again, let's plug in x equals minus 8 this time into our function, to give us 4 times minus 8 plus 2 in a modulus, minus 1, as shown. And tidying up the bit in the modulus first gives us mod minus 30, and then minus 1 tagged on at the end. Now, since minus 30 in the modulus sign is negative, we need to make that positive. So we have 30 minus 1, as shown. And this is, of course, equal to 29. Finally, for part C, we're required to find the value of f of minus 1 over 4. So let's plug in x equals minus 1 over 4 into our function, to give us 4 times minus 1 over 4 plus 2 in modulus, minus 1. as shown. And tidying up gives us this expression, which equals mod 1 minus 1, which of course equals 1 minus 1, since mod 1 is already positive, so we leave that as it is. And this equals 0. We're now going to take a look at sketching the graph of y equals mod ax plus b. In order to sketch this, begin by sketching y equals ax plus b, i.e. simply ignore the modulus sign. So if we're looking at y equals x, then we simply sketch y equals x and not y equals mod x. Then if we want to look at sketching y equals mod x, we reflect the section of the graph below the x-axis in the x-axis. The bit below the x-axis has now been highlighted with a dotted blue line as shown. Let's now reflect this in the x-axis as shown here. This gives us the graph of y equals mod x. Now let's sketch y equals mod 4x minus 1. Again, let's ignore the modulus sign and simply sketch y equals 4x minus 1 to give us this graph here. Next, reflect the section of the graph below the x-axis in the x-axis. So here's the bit which is below the x-axis, highlighted with a blue dotted line. We're going to reflect this in the x-axis, as shown, to give us y equals mod 4x minus 1. You can check that this is correct by plugging in a few values, as shown. Now let's have a go at another example. We are required to solve mod 3x minus 2 equals 3. So let's solve this. We begin by sketching the left-hand side and the right-hand side separately. So first sketch y equals 3x minus 2 rather than y equals mod 3x minus 2, as shown here. Next we sketch y equals 3. So clearly there's one solution here. However, this is the solution for y equals 3x minus 2, not y equals mod 3x minus 2. So let's sketch y equals mod 3x minus 2. We need to reflect the section of the graph which is below the x-axis in the x-axis. This has been indicated by a blue dotted line, and reflecting it gives us the graph as shown. As you can see, there are two intersection points. We're going to label them A and B and solve. The point of intersection on the original part of the graph is at A. Therefore, 3x minus 2 equals 3 at this point. And solving this gives us firstly 3x equals 5, and then x equals 5 over 3, which is of course equal to 1 2/3. And now for point B. The point of intersection on the reflected part of the graph is at B. So we have minus 3x minus 2, as shown, equals 3. And solving for x, we have 3x equals minus 1 to begin with. And this, of course, implies that x equals minus 1/3. So here are our two values of x. So the solutions are x equals 1 2/3 and x equals minus 1/3. Now let's have a go at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So in example 5, we're required to solve mod 4x minus 3/2 equals 1 minus x over 2. We need to begin by sketching the right-hand side and the left-hand side of the graphs of this. This will help us to understand the question and also solve for x. So here's a sketch. We have y equals mod 4x minus 3/2 in red, and we have y equals 1 minus x over 2 in blue. There are clearly two intersection points, so we're going to find two solutions for x. Let's examine part A first. The point of intersection on the original part of the graph is at A. Here we have 4x minus 3/2 equals 1 minus x over 2. And solving for x gives us that x equals 5/9. The point of intersection on the reflected part of the graph is at B. Therefore we have here minus 4x minus 3/2 equals 1 minus x over 2. And solving for x gives us that x equals 1/7. And therefore we have two solutions, x equals 5/9 and x equals 1/7. Now let's take a look at part B. We are required to solve the inequality mod 4x minus 3/2 is greater than 1 minus x over 2. We know from part A where the two sides are equal. So mod 4x minus 3/2 equals 1 minus x over 2 at x equals 5/9 and x equals 1/7. So we know that these are critical points. Before these values and after these values, something changes. Let's take a look. The shaded region, as shown on your graph, is where mod 4x minus 3/2 is greater than 1 minus x over 2. And this is where x is less than 5/9. However, there is another region where this inequality also holds, and that's here, the second shaded region on the graph. This is where x is greater than 1/7. This brings us to the end of this session. If you have understood its contents, you should be able to understand and use the modulus function. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to it.